Next presentation.
I am Andi Ammar Akrar from Group 4 and have a good time watching.
Well, let's just do the problem. Our problem is solve the logarithmic equation algebraically and check using a graphing calculator for ln x minus ln x minus 4 equals ln 3. The first thing to do before working on this problem is to determine the domain of its natural logarithm. As we have learned in calculus course that the domain of the natural logarithmic function is the set of positive real numbers. And the first thing to do to determine the domain is to determine split points. Because on the left side, on this equation, we have two logarithmic function. There are ln x and ln x minus 4. Then we also have two split points. There are x equals 0 and x minus 4 equals 0. Or x equals 0 and x equals 4. We all know the domain of the natural logarithmic function is a positive real numbers. So we need to change the two split points that we have in the form of positive real number, then determine the intersection of them. So that we get x greater than 0 intersection x minus 4 greater than 0. Or in other words, we have x greater than 0 greater than x greater than 0 intersection x greater than 4. Because the result of x greater than 0 intersection x greater than 4 is x greater than 4. So we have the domain of ln x and ln x minus 4 is x greater than 4. Back to our problem, which is ln x minus ln x minus 4 equals ln 3. We can actually change the form to a simpler form by applying one of the properties of the natural logarithm. Now look in here. We can change ln x minus 4 equals ln 3 into ln x over x minus 4 equals ln 3 because they are equivalent. This we get from applying the third property of the natural logarithm, that is ln a minus ln b equals ln a over b. Now we need to note that ln is a logarithm with the base is e or Euler and has a value of 2,7182 and so on. Therefore, because the base of the logarithms in the two sides are the same, we are allowed to remove the logarithm sign so that we get x over x minus 4 equals 3. Now we just have to find x. We can multiply both sides by x minus 4. So it will be x equals 3 times the value of x minus 4. Then we can multiply x minus 4 by 3 in here. So now we have x equals 3x minus 12. Next, we move it 3x to left side so that 3x changes the sign and becomes minus 3x. And now we just subtract x and 3x so that it becomes minus 2x. And now we just have to divide both sides by minus 2, so we have minus 12 over 2 on the right side, so that we get x equals 6. keep in mind that at the beginning we have determined the domain of this problem, which is x greater than 4. And because 6 is in the domain area, then x equals 6 fills our set of the domains, and our answer is correct. To be sure, we can try using a calculator for the problem ln x minus 4 equals 3, and since we already have an x value which is 6, so we can replace x with 6 into the equation, so that the equation becomes ln 6 minus ln 6 minus 4 equals ln 3. Then we can simplify, subtract 6 and 4, so we have ln 6 minus ln 2 equals ln 3. When we find the values of ln 6, ln 2, and ln 3 on a calculator, then we will get values like this. Ln 6 equals 1,79176, ln 2 equals 0,693147, ln 3 equals 1,09861, and then so that the result of ln 6 minus ln 2, when we convert it to the actual value, will be the same as will be the same as 1,79176 minus 0,693147, and it will be equals to 1,09861, and we know that 1,09861 is the value of ln 3 in here. So we get the conclusion that ln 6 minus ln 2 equals ln 3 is true, or in other words, x equals 6 is correct for the solution of the equation. If you still want something clearer, please look at the chart that I have created using the GeoGebra application. In here we can see clearly the model from the graph of ln x minus 4 and ln 3 here, and it can be seen that the axis of the intersection of the two is x equals 6 in here. Therefore, our solution is correct. Maybe that's all from my explanation. You can ask me if you find anything that is not clear, and thank you for watching.
Next presentation.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, I am Miftahul Jannah. I will explain the question about logarithmic function and graph. Next, this is the question. For the following function, briefly describe how the graph can be obtained from the graph of a basic logarithmic function. Then, graph the function using a graphing calculator. Give the domain and asymptote of each function. Fx is equals to log base 2 of x plus 3. Okay, so I will explain how to solve the question. There are fx is equals to log base 2 of x plus 3, where 2 is base and x plus 3 is numerous. The formula of determining asymptote is numerous should equal to 0. So x plus 3 is equals to 0 and x is equals to minus 3. Whereas the formula for determining domains is numerous should be greater than to 0. So x plus 3 greater than to 0, x greater than to minus 3. Okay, next, we make a table of logarithmic function with 3 rows and 6 columns. So here's I have been determined the value of x. They are minus 2, minus 1, 1, 5, and 13. Then I want to find is the value of y. Okay, for x is equals to minus 2, y is equals to log base 2 of x plus 3. Y is equals to log base 2 of minus 2 plus 3. Y is equals to log base 2 of 1. So, y is equals to 0. For x is equals to minus 1. Y is equals to log base 2 of minus 1 plus 3. Y is equals to log base 2 of 2. So y is equals to 1. Okay, for x is equals to 1. Y is equals to log base 2 of 1 plus 3. Y is equals to log base 2 of 4. So, y is equals to 2. Okay, next, you can see the result of the y on the table. Next, for x is equals to 5. Y is equals to log base 2 of 5 plus 3. Y is equals to log base 2 of 8. So, y is equals to 3. For x is equals to 13. Y is equals to log base 2 of 13 plus 3. Y is equals to log base 2 of 16. So, y is equals to 4. Then, you can see that dx and y are minus 2, 0, minus 1, 1, 1, 2, 5, 3, and 13, 4. Next, therefore, we can get the result and then we draw the graph. The picture of the graph is shown in this slide. Okay, next, we prove by using calculator. It appears that the graph we obtain is same as the graph that we graphed before. Okay, I think enough for me. Thank you very much.
The last presentation.
Hello everyone, back to me. I am Masyta Nurfadya. I will explain the question number 20. The question say make a hand-drawn graph of the function, then check your work using graphing calculator. f of x equals 1 plus Euler to the power of minus x. So, the answer we know, guys, f of x equals y. We can substitute f of x into y. So, y equals 1 plus Euler to the power of minus x. Anyone knows what is Euler? Euler is a constant number similar with p. The value of Euler equals 2.71 and so on. To find the value of x, y as the order pairs, first we have to make a table and the second plotting on the coordinate plane. Look at, this is our table. The first column of the table is x as the input. The second column of the table is y equals 1 plus Euler to the power of minus x, where y as the output. The third column of the table is x, y as the order pairs. We use this for plotting on the coordinate plane. Let's see how to find the value of x, y. The first row of the table is minus 2. If we input the value of minus 2 into equation, in other words, if we substitute minus 2 for x into our equation, then we get 1 plus Euler to the power of 2 equals 8.38. So, which is mean y equals 8.38. Next, the third, if we input the value of 0 into equation, then we get y equals 1 plus Euler to the power of 0. Guys, remember the properties of exponential function. If Euler to the power of 0 equals 1. So, which is mean y equals 1 plus 1 equals 2. So, y equals 2. Next, the fourth row of the table. If we input 1 to equation, then we get 1 plus Euler to the power of minus 1. Remember again the properties of exponential function. Euler to the power of minus x equals 1 over Euler to the power x, which is mean y equals 1 plus 1 over Euler equals 1.36. So y equals 1.36. And finally, guys, we find the value of x, y as the order pairs. That is mean we can graph all of the pairs of inputs and outputs on the coordinate plane. Look at, this is our coordinate plane. Here are the points from our function table plotted on coordinate plane. And here is the results graph we get if we connect those points. It forms decreasing of the graph exponential function. Compare with graphing calculator. It seems exactly same. That's all for me. Thank you.